Now we start talking about different types of facade systems, what they do. So mainly these are the systems still used and in practice. So we start with the stick system, what it is. That was an old invention. When people found glass or other material, they found an easy way to stick something onto the wall. So example, this is improved versions of system. The evolution has brought them in with material, with glass, with aluminum, with steel, with wood, what and what not. So the systems are mainly into these three categories: stick system, semi-unitized system, pressure equalized fully unitized system. So now let's see what is stick system. A control system in which the mullions are installed first with transom and the glass panels are inserted into the mullion framing in the field are great. What it is? So you make a grid when you're building. So you have a facade of a building where you create grids using steel, aluminum, wood or whatever. So you make vertical line, horizontal line to the requirement of architect and client. Then you start putting glass piece by piece at site. How you do that? Labor intensive. And when you design such big buildings with stick system, they don't perform unless you have a system where it can take care of all the impact. So the invention came into place. Yes, still they practice stick system in certain part of the world, but it's almost taken out of the facade field. You can use it maybe in small buildings where you have 1 floor, 2 floors, where you like to do some sort of small work where it doesn't have too much of impact from the nature. There we can start using it. Otherwise, stick system is an old invention where people used it when the technology was not available or the systems were not available. But today there are good systems available, but it is very labor intensive. Today the world doesn't have skilled workforce to execute your work. So think loudly. Choice of systems and limitation of systems play a major role in designing a facade. So stick system invention has gone. So what people thought, okay, how I am going to go forward? What's going to happen? So they started to understand how I can bring little bit work towards my factory. Here they started getting lot of quality. See, example, I have to install 1,000 glasses at site by fixing each piece by hand. Impossible nowadays. So they started understanding all this problem. Plus they don't move, they don't expand, they don't contract, even though the design is there, but there are a lot of limitations. So then the invention went to a semi-unitized system. What they do with the semi-unitized system? A control system, same, but they dislodge the glass and made it in the factory, and they bring in the glass with the frame and fix at site. Still, it is a form of stick system, but little bit advanced. In a way, they add a little bit of movement into the structure. The structure can move, that can expand, that can contract, but still semi-unitized system is labor intensive. You need to have a big workforce. Again, you install 1,000 pieces of glass at site. It's madness. You can't do it. How you supervise them? So still the questions were asked. How I am going to have a system which can take care of everything which is happening around us, which including a skilled workforce, safety, and so on and so forth. So the invention went up to say, yes, I want to have a system which can be done at ease, less labor intensive, but at the same time taking care of all movement. Yes, semi-unitized system still can be used, still it's in use in certain part of the world, but with limitations. The limitation is, yes, wherever you need a faster changing of glass example, but that also got nullified today. But people started understanding, like small offices or shopping malls, or talk about airports. Yes, there they can use a semi-unitized system where you don't have a lot of movement, lot of factors in form of whatever factors we discussed before, like thermal expansions and other factors, limited factors, then you can use a semi-unitized system. Otherwise, today's environment and buildings today require you to think for something more advanced, but at the same time, it should take care of all these factors. Number one, you don't get skilled workforce today in any part of the world. People are not ready to go and work in the field. So what you do, you still sit down and say an adamant, no, I don't want to improve, this is what I know I want to do. No, they have found different systems where all this can be minimized. So then came a pressure equalized system. Here what happens is, if you see the previous slide, again here, mullion is attached as a grid like in the semi-unitized, and then the glass is fitted at site. But when you go to unitized system, everything is done at factory. It means floor to floor or 2 floors or whatever module, the grid you form, you make everything in factory. And you bring them together and you install at site. So it means people work from inside, you don't need to have external access to the building. You do everything from standing inside the building. It is safe, less manpower. The system itself, it's more advanced, which went to take care of all your factors, building movement, creep, expansion, contraction. So unitized system is the system available today which takes care of all these functions. Possibly the best system you can design for your building. So lot of advantages and disadvantages are there. Okay, commercially, yes, it may be slightly expensive, but you need to understand how to work around it with different systems. However, understanding the limitation. If you do not have a skilled workforce, and if you are adamant to say, yes, I want to put 100 people at site to put piece by piece glass, rather I will get 20 skilled people, I will ask them to work in factory under tight supervision. So pressure equalized fully unitized system. This is what we are going to see in the presentation, because I didn't want to go back and explain how the stick system works or semi-unitized system works. If we can cover the pressure equalized system, that will give the transformation as well, how it got transformed to this level. So today commonly in the world, this is what they use for all the high-rise buildings. This unitized system have made a big impact in the world in form of design. So the whole world today believe this is the way to go, and that's what it is happening. All tall buildings, no matter where, which part of the world, most of them or all of them I can say are done with a unitized system. So now let's start understanding what is pressure equalized fully unitized system. When you talk about a pressure equalization in a curtain wall system, there are 4 factors which governs the design. One, a 4-way joint, if you see here of a panel. 2, a PE chamber, we call it a PE chamber. What is PE? Pressure equalization. I will talk about this after this. Then a joint which moves. It means you saw a mullion in semi-unitized system where it is a solid box, but here they split the mullion. They make it move. But what will happen in semi-unitized system when there is a thermal expansion? It will be taken care of by the gaskets, which is not good. So, but here the system itself will expand and contract. Then a bracket. See, this is the bracket you use to hold it to the structure, but at the same time taking care of all the building movement. So now let's understand each and every component of this. If you see, there are 2 panels which put together by means. Now they are creating a 4-way joint. So it's a simple simulation to show how panels are put together. Like example, this one panel, imagine floor to floor. Now your second panel, you join this panel and then you bridge them. understand and put all the details what is required in the design together. So, you created a good intersection of joint which is considered as critical while you start designing. How these things are done? So, understanding a unitized wall, it is as simple as you are building a wall, unitizing it in a factory environment. So, it is like manufacturing a furniture, you loose furniture. What they do, they manufacture the furniture in the factory, they assemble it at site. I mean, they put a few screws, then you have a furniture. But in this case, the same, you make a full panel like what you see in the building. Say example, this is a full floor, whatever you see here. So, this is a complete unitized system of panel which brings the whole thing together. So, you put the panel, you go in detail to understand the design, then you have your panel 4-way joint clearly done and it is ready. So, this is what I was explaining about pressure equalization. What is pressure equalization? Always we start looking at external and the internal pressure, and your wall which you create stands in center. So, external there is a pressure which is always higher, and internal there is a pressure which is always weaker. So, we call it in engineering term positive and negative. So, it means your wall whatever you design should withstand both. So, you are applying pressure outside because that is a natural pressure created by wind and other factors. Then internally what happens? There is a suction because you created a barrier. So, the barrier is your curtain wall. So, if you make a curtain wall too tight, too what you call a rigid or too sealed, what will happen? They have to be heavy because you are not letting the air to pass through. So, you are containing the air with the system. So, you design the system to make sure you let the air to pass through, but not to create a heavier suction inside, because internally what will happen, as it is weak, always you have the tendency of pulling anything inside. So, while you design a system, the first 4 factors you have to see is 1, 2, 3, 4 what is written here. A rain screen. So, it means if there is wind and water together, they will find a way to go into your building. So, you want to shelter the building against wind and water. So, if you start talking about rain screen, so you control the water getting in through the joints, because this joint what you see here is called a stack joint. What is a stack joint? You have floor to floor, a building moves because of creep or settlement, they start moving. So, you need to create a stack where the mullion or the transom can be split, so they move inside each other, which allows, in the next slide I will explain in brief how the movement is taken care. But when you talk about pressure equalization, you have to equalize the internal and external pressure by letting them to go inside the chamber, but in a calculated way. I cannot say I make a big hole here into the system to let my water to go, air to go in through here, where I do not have anything happening on the internal part. This is inside the building, this is outside the building. So, internally as I have a negative pressure, outside I have a positive pressure. So, air is blowing here. So, internally I have a suction which is pulling in. So, what will happen if I let the whole air to pass through? When there is water, they all drive inside. So, it does not work. So, you need to create a design which takes care of all these factors. So, the design should take care of all these elements, and you should know how to do a pressure equalization. So, it is not just as simple as I am saying. So, your design have to take care of how much air I let to go in, and these are the chambers. You see here, there is a chamber 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 here. So, the air which goes through the system should have a control. It means it should be in a controlled way. You cannot just let the air to pass through and then you say the system is not working. So, you control the air pass through the system and you equalize them here. It means the air coming here into the chamber and this air the suction getting weaker and weaker. So, you do not get too much of suction happening. So, whatever is happening you equalize them here and make it 0. So, at the same time you need to design the system as such. Say example, if I do not create a air cell, this is called a air cell. It means I need to seal the air coming through the system, because this system is split. This is upper floor, this is floor below. They two of them join at somewhere around the floor level. This is your floor level. So, they join, but you allow them to move. When you allow them to move, you should take care of all these seals which they play a major role. Right. This is a vertical section of your building where you start to see the head and sill happening. We call this as a sill and we call this as a head. So, you allow them to move, and what happens? If there is wind, for sure there will be water, but we have to control the water. Still there will be droplets of water which can get into the system with the wind, that you collect here. This is what we call gutter. You collect the water like the gutter in your buildings. You collect the water there, but very negligible, because you are not letting too much of water to go into the system at first place. So, they start draining off. And one more most important thing while you are designing this, you have to take care of capillary action as well. What is capillary action? If any suction is there, i.e., you have air under pressure, you have water. So, if you allow air to escape, they will push the water up. It means, say example, I do not have this air seal. Now, what is happening? This air seal is weak, so my suction is there. It means I am pulling the air. Now, whatever water I will have here, or even if anything goes wrong with this, water will start going in, because you do not have a proper air seal. So, this is what you call a capillary action, because the air is sucking inside. It can raise several floors. I have personally seen a lot of failures where you can see water rising for 2-3 floors inside a joint. So, whenever you design anything in facade, make sure your air seal is proper and tight. Here, yes, you can have sometimes damages or whatever, but if your air seal works right, then this can be managed, i.e., the failure can be managed. If your air seal breaks, even you put a pinhole here, small hole, they will suck inside. So, be careful when you are attending to a design, whatever form, you must ensure your air seal is in order. So, this stack joint, as I explained, is designed for movement. So, the 4 important factors: rain screen, pressure equalization chamber, air seal and weep. What is weep? Weep is nothing other than like our 2 eyes, right? You weep. So, any excess water or any water which gets into the gutter, they have to drain out here. So, we make few holes on the head for the water to get out, if there is a water. Most of the time there should not be any water inside the system, not much as we think, because it is controlled. If air seal fail, then yes, you will have a lot of water, but still you have to find a way to drain them off. So, you make holes in the system to drain it off. So that's how you work. So if you go back, you look at the four-way joint of the system, which is critical, because you put two panels together, you must understand how to make a four-way joint. And second, when you design the system, make sure we understand this concept, rain screen, pressure equalization chamber. It's not only at this point also, but in the horizontal as well. If you look at the previous slide, you see the vertical, if you see this mullion which comes in, there also you make a pressure equalization chamber. So, rain screen, pressure equalization chamber, then air seal, the most important one, and then weep. If there is any excess water, you throw it off. That is how you start with the design. Now, let us start understanding the stack joint in depth. See, we call it a split transom. What is a transom? You in a building, you have a horizontal beam. Example, that your column is called as mullion. Your beams are called here as transoms. But here, when you the same terminology you can use in anodized wall. What you call anything vertical, you call it column. So anything vertical here, you call it mullion. Anything which is horizontal, the beam, so you call here as transom or mullion. Sorry, split transom or transoms. So the terminology goes like that. So to make all understanding it easier, so what you see here, this is called as head, like our head, right? And this is called as sill. It means at the lower level, because this joint happens at the floor level, because it gets connected to the floor below this panel. So here later I will show you how it gets engaged to the structure. So this we split the mullion. What it does? It has to be designed for thermal movement. Okay. In this case, what you see here is an aluminum system. It's an advanced aluminum system, where aluminum, it's prone for expansion and contraction with thermal. If there is excess heat, it expands. If it is cold, yes, of course it contracts. So throughout the day, throughout the year, they start moving. That also can be calculated. Sometimes you do for 1 millimeter or 2 millimeter, but it can be calculated. So your design have to take care of the thermal movement. If I make a rigid system, what will happen? They will tend to bulge out. That can create a havoc for your building. Then live load and dead load. Whatever loading which you have to consider while designing the building. So there can be an impact load, there can be a dead load. Of course, the dead load is the self weight of the panel plus the factors. What you call about live load? Live load, there can be human interface, human impact, plus your wind load, plus your other loads what we consider we have to add. So all this put together, you have to arrive to a factor that have to be considered in the design. And third one, most critical one, wind load. So the system what you design have to take care of wind load as well. See, when wind is blowing, sometime you have typhoon. If you start to get a too rigid system, what will happen? It will become very, very, very hard, and then sometime it will end up to break, or it will get too rigid. So you allow the system to bend to its limitation. So you design it with factors, you design it with safety. So you don't make a system which is too tight, you make it little bit flexible. So considering the wind load, you have to allow the system to move. Like example, when I am moving my hand, of course there is a joint here, but this joint is not fixed, they are held together by means of nerve and flesh and skin. But if you see two bones, they are not connected. Similarly here, you look at your stack joint, they are not connected, they are split. So they let them to move. All these factors, ground movement leading to building settlement. Yeah, buildings, they start going down. Negligible amount, sometimes it can be bigger. Certain buildings, have gone even 2 foot, 3 foot down after construction. So, the system have to take care of those things, those elements, those factors are very important. So, the stack joint is very critical. When you design a system, a stack joint plays a key role to take care of all those factors what we explained. Now, what we are seeing is a mullion. You do not do only with the head. Here also you make a system which, if you see the movement, it has to move. See, the mullion is also split, which allows them to expand and contract horizontally as well. A stack joint, what we saw here, which goes vertically up down. Okay, so building, when it moves or anything happens with seismic and all of the movement, they move up down. When you start looking at horizontally, the mullion also is split. So, they can move and close. So, this is how the system is designed. So, the mullion also is split in a way which allows the system to completely move forward. So, now what we are seeing is how you attach. This is a simple form of attachment. So, you saw the panel, now you bolt the panel to the structure. The unitized system are installed into the building structure by use of bolt or anchors or casting anchor. There are a lot of anchoring devices available, but a commonly used one we will discuss later what people use. And bracket joints. This is a simple form of fixation. This is the only one you do in that side. So, this is your casting channel, this is your bracket. You do all your setting out, in and out, where you want the bracket face to be. So, you have serration here, which allows the locking of horizontal movement, and this bracket design itself will take care of all sort of tolerances which is required at site to get a good system fix. And then what happens here, it transfers the dead load. So, the bracket design takes care of dead load first. Second, it takes care of restraint as well against the wind. So, both directions the bracket will play a major role. So, whatever load getting transferred here, that goes down to the structure by means of brackets. Finally, it will get converted as a small point load onto the structure. So, your bracket plays a key factor as well when you design the system. So, this have to be taken care by engineer considering all the factors. How I will design a bracket, what are the loads I have to consider, what are the factors, safety factors. So, it is a simple form of design for a bracket. Now, I am going to run a small video to show how this panel is getting engaged, a unitized panel. So, if you run the video. So, this is the structure. Now, we put a casting anchor onto the structure. So, what they do, so now they are setting the bracket. So, if you look at here what they have done, there is a casting channel. You see that horizontal thing what you have here, this is what we call a casting channel. So, you embed this while doing a casting, and then you introduce a T-bolt into this channel. This is a T-bolt. You go inside and you lock them, and then you put your bracket. So, you see the bracket you are adjusting with the slot, and you lock them in position with the serrated washer. So, horizontally you do, the thing will move, because when the building is shaking, you have to let the thing to move. The whole system has to move like what I am doing now, right. But if you start going in and out, then the whole thing will get distorted. Horizontally when they move, it is okay, because it goes along with sway of the building. So, you lock them in position wherever it is required, and you are ready to receive the panel. Now, the panel comes from factory fully done. You put them there and you drill 2 bolts. It is a simple form of fixing the system. So, you see you put 2 bolts, you attach them, you are done, that is it. The panel is installed. So, what you see here, this is a gutter head what we saw the split mullion, it happens slightly above the floor level. This is a mullion waiting to receive the other panel. So, the stack joint, now you have the head portion of the panel. So, now the next panel will be installed you can see now they connected floor to floor. So, the next panel comes down, they use a crane or something to lift the panel, they bolt them together. So, you keep doing it. See the size of the panel, it covers floor to floor and it is done out of factory. So, you keep going, you keep installing the panel as you go. So, bolt it, keep bolting, and then this is where the 4-way joint happens. Now, once you finish installation, you do whatever design requirement is, you seal the head, you put your gutter, everything cleaned up, then you bring the next panel. So, this is where your sill going to happen. If you start looking at the video again, you see they create a 4-way joint and then they keep going. So, once again without stopping. So, you put your channel, you put your T-bolt, then you put your bracket, adjust the bracket for movement, whatever in and out based on the tolerances of structure, then lock them in position. Your field work is done, that is all you do. Then you wait for the panel from factory, you attach them with the bolts, 2 bolts, simple, you are done. So, look at, imagine this panel what you see here got 3 glasses plus spandrel plus. All the other systems what you do, you install all these at site. What you see here is, okay, you have 1 glass, 2 glass, spandrel. Unit system you do it in factory, you bring them all together and you put it up. But the other systems what we saw before, you just to do the grid, you put all the mullion, transom, then you do the glass piece by piece at site. So, hope you understand unitized curtain wall by now, because we have to spend a lot of time. I have given you a very brief fundamental, simple fundamental, how the unitized system is done and why, and it is being used as a comprehensive system nowadays. So, it takes care of contraction, thermal expansion, wind, whatever we saw before. So, the system is designed for all this and is a most advanced system.